So let us now attempt question 30 on page 343. So again, please have a go at these questions yourself and then follow along with my answers. So it says, how many moles of water can be obtained from 25 ml of a 0.150 molar concentration of ethanoic acid? So the first thing I'm going to do here is we can see, again, we have it molar, and it's asking for the moles of H2O. So we have 25 milliliters, and we have 0.150 molar. So we need to compare our total amount of moles. So we go molarity is equal to moles over volume. So the molarity, which is 0.150, is equal to the number of moles, which we don't know, over the volume. Now, again, be careful here because this is in milliliters. Now we move this around over here so that we multiply them together, meaning that the total number of moles is equal to 3.75 times 10 to the minus 3. Now, we want to try and find out how many moles of H2O. So this is going back to our previous module, and we need to have a look at the different ratios between these two compounds and take that coefficient into account. So we can see here that we have a 2 in front of our ethanoic acid, but there is only a 1 in front of the water. So we need to divide our moles by 2. So the number of moles is going to equal 1.9 times 10 to the minus 3, which means that our total amount of water, so the moles of H2O, is equal to 1.9 times 10 to the negative 3. So let us now look at question C. So what we do here is we need to look again at our ethanoic acid, which is over here. So we know that it has a molar concentration of 1.25. So this is where we go to ourselves and go, okay, so what do we need to find here? So a good way to do this is I write the formula. So I'll go molarity is equal to moles over volume. So the question is asking for volume. We don't have the moles, but we do have the molarity. So this gives us an indication to go, okay, we need to try and target moles. Because we can do that because we have our information here from our potassium carbonate. So we look at our potassium carbonate, we go, it is 0.750 molar, and it has a total volume of 75.2 milliliters. So we now convert our molarity into moles for the potassium carbonate. So molarity is equal to moles over volume. So the molarity, which is 0.750, is equal to the moles, which we don't know, over the volume, which is 0.0752 liters. And that's going to give us a total mole concentration of 0.0564 moles. So I'm going to put a little square around that. Now we need to pay attention as well to our coefficients at the front here. So we have a look at potassium carbonate. So we look at potassium carbonate, so that has nothing in front of it. Then we look here at our ethanoic acid, which is over here, and so we have our 2. So we've got 0.0564 multiplied by 2, and that will give us 0.1128 moles of ethanoic acid. Now we're getting somewhere, because now we can see here, so what information do we have? We have the molarity, which is awesome. So we know that the molarity is 1.25. We now, down here, we have our moles. So now we can calculate our volume. So molarity, which is 1.25, is equal to the number of moles, which we have down here, which is 0.1128 moles, over the total volume, which we don't know. So we see here the operation is a divide. So if we move this over, it turns to a times, which means when we move our 1.25 over so that we have the volume isolated, that turns into a divide. And that means that our total volume is equal to 90.2 milliliters. Okay, let us now move on to question 55, page 345. Okay, so let's start. The question states, what is the molarity? So I'm going to put my square brackets around that, of a phosphoric acid solution if the solution is 85% by mass H3PO4. So that's phosphoric acid. And it has a density of 1.7 grams per mil. So this is one of those questions where we look at it and just go, well, where do we start? What do we do? And the answer is we need to look at what we have to find. So this is where I look at the end, what they want, and we work our way backwards. So I go molarity is equal to moles of the solute over volume of the solution. Now I've got a little bit of a target as to what I need to find. Now, we need to find the volume of the solution. So how can we do that? We haven't really been given anything, but we have been given the density. So we know that the density of the solution is 1.7 grams per mil. So what we can do is we can multiply that by 1,000. So if we have the density is equal to 1.7 grams per mil, and we multiply this by 1,000, what that will give us is 1,700 grams per 1 liter. Now we're getting somewhere, because what we just did then is found out the volume of our solution. So we know that our volume is 1 liter. Okay, so now what do we do? So we've got our volume. We now need to find out our moles. So remembering that moles is equal to mass over molar mass. So how do we know the mass of our solute? Well, we know the mass of the overall solution, which is 1,700 grams, and we also know that the phosphoric acid is 85% by mass. So we can go 1,700 grams multiplied by 0.85, and that will give us 1,445 grams. So now that we have our grams of our phosphoric acid, we can then put this into our moles equation. So moles, which we don't know, is equal to 1,445 grams over the molar mass. So 1,445 divided by 98 will equal to 14.75 moles. Okay, so we know our moles of our solute, which we can tick up here. So that means that our lucky last final step is we go molarity is equal to the number of moles, which is 14.75 moles, divided by the volume in liters, which is 1 liter, meaning that our molarity is 14.75. So let us look at the next one. So page 345, question 61. So automobile battery acid, I don't know why they couldn't say car, but it has to be automobile. Battery acid is 38% sulfuric acid and has a density of 1.29 grams per mil. So calculate the molality and molarity of this solution. Okay, so we've got a similar problem to the last one. So again, I'm going to write out that molarity is equal to moles of solute over volume of solution, and that molality is moles of solute over mass of solvent. So we've developed ourselves a little bit of a checklist here. So we know that in order to solve this question, we need to get the moles of solute, volume of solution, and the mass of the solvent. So how do we do this? What's our first step? Again, we have a density of the overall solution. So that's our best approach. So the density is 1.29 grams per mil, and we need to find the volume of the solution in liters. So the easiest way to go about that is, again, multiply our density by 1,000 so that we know how much it weighs per unit volume of the solution. So we go the density, which is 1.29 grams per mil, multiply that by 1,000, and that will give us 1,290 grams per liter. So we now know the volume of our solution because we know that we have 1 liter. That's what we've assumed. So now what we're going to do is we're going to look at the mass of the solution. So the mass of the solution is equal to 1,290 grams. Now, to get the mass of the sulfuric acid, we need to multiply this by 38%. So the mass of sulfuric acid is 1,290 multiplied by 0.38, which means that the mass of that is 490.2 grams. Now we can use the mass of our solute to calculate the number of moles. So moles, so I'll separate that. So moles is equal to the mass, which is 490.2 grams over molar mass. We get 98 grams per mole. So 490.2 divided by 98, that gives us 5 moles of sulfuric acid. So I'm going to put a square around that because we've just got another 2 things off our checklist. The only thing that we need now is the mass of our solvent. So how do we find out the mass of our solvent? Well, we know that we know 2 things. 1, solute plus solvent equals solution. In addition, we know the mass of the solute, which is 490.2 grams, and we know the mass of the solution because of the density. So we know that the mass of the solution is 1,290 grams. So there is an addition that's separating these two. So if we were to rearrange this, it turns into a subtraction. So 1,290 minus 490.2, that will give us 799.8 grams of solvent. Now we have all the pieces. So what our next step is to put them all together. So if we look at the molarity, so molarity is equal to the moles of solute, which is 5 moles, divided by the volume of solution. So the volume of the solution, which we found up here, was 1 litre. So we go divided by 1 litre. That means that the molarity is equal to 5. So that one was nice and easy. The next one is our molality. So molality is equal to the moles of solute, which we got up here, which is 5 mole, divided by the mass of the solvent, which was 799.8 grams. Now, don't forget that molality is in kilograms, not grams. So we need to convert this into kilograms, which is going to be 0.7998. Meaning that 5 divided by 0.7998 gives us a molality of 6.25. And that's how we can calculate the molarity and the molality by just given the density, the formula, and the percentage. Okay guys, so that basically wraps up Module 9 Video 2, so thank you all very much for joining me. I hope you all enjoyed this video. If you all could please complete the survey just down below, it really does mean a lot. I understand there has been a few surveys, but they do give me a lot of very valuable feedback and allow me to improve these videos and make them as high quality as I can. If you do have any questions, queries, or any suggestions, please feel free to email me at b.grant@griffith.edu.au. So thank you all very much for joining me. Best of luck with all your studies, and I'll see you all next time.